In this video, we're going to work another application problem where we're going to form an oblique triangle using vectors. So here we have the problem. An airplane flies 32 degrees for 210 kilometers and then 280 degrees for 170 kilometers. How far is the plane from its starting point and in what direction? So we have two pieces of information. We have a direction and a magnitude, a distance, and we're asked to find direction and magnitude or distance, which means we're dealing with vectors. One thing we want to keep in mind is that in these problems, we're just given a degree measurement. So this is navigating clockwise from north. So most of the time when we are navigating, we start at north. North is 0 degrees, and we travel around like this clockwise. So east would represent 90, south 180, and then west 270. Okay, so navigating, this is generally, if you're not specified and you're given some sort of navigational problem, you're going to be calculating your degrees based off 0 at north and traveling, again, clockwise. Okay, so let's start. Where do we start? So I'm going to give myself a set of axes to represent north, south, east, west, and I'm going to start at point A. And this says I travel 32 degrees. So 32 degrees off of north is just this little distance right there. And then I will draw my vector out from 32 and I will label it as 210 kilometers. So now I'm at point B. At this point, we'll make another set of axes. And from here, it says we travel 280 degrees. So now remember that is off of north, and 280 degrees is going to take us about a little bit over here into quadrant 2. So 280 degrees is a little bit past, and we're going to travel 170 kilometers. So I know my picture isn't perfect here, but this angle right past 270, we know we have a 10-degree angle in there. All right, so how far is the plane from start and in what direction? So we went from B to this terminal point, and again, this should have a direction to C here. So my resultant is the vector from A to C. So we need the magnitude of that vector. I'll call that side little b. And then we also need the angle. So the angle that we are ultimately looking for is off of north and all the way around here. That would be the direction. And we're always going to state that direction from where we started. So we know we are looking for the distance, which is going to be the length or the magnitude of that vector. And since we have this vertex as capital B, the opposite side will be little b. While we're at it, we are interested in angle A. If this is angle A, then the opposite side, this blue side up here, 270 is going to represent little a. And also we have angle C, so that means my red side, 210, is going to represent little c. So as I work through these problems, I know I've got my nice diagram here, which we definitely want to keep, but sometimes I find it helpful to just, extrapolate, pull that other triangle out, try and make it look about the same. It doesn't have to be perfect. We have A, and over here little c is 210. We have over here B, we have A equals 170, and capital C, B is one of our unknowns. So we need an angle to get going. I don't know much about this, but I do know two angles up here which will help me. So since I know between this vertical line and my vector C here, so since the vertical line and vector C, I have this angle 32, I also know that this little angle right here is 32. So interpreting that, if that's 32, then this must be 58. And if this piece is 58 plus that 10, we know this angle B then is going to be 68 degrees. So we have to do a little bit of logic, but now we see we have a side angle, side triangle. We know the included angle. And when it's side angle side, that means we're going to use the law of cosines. So since we are masters at law of cosines and law of sines now, I'm just going to set this up for us and kind of tell you what the answer is. So if we were looking for side B, we would end up with a law of cosines formula, which looks like this. So technically we would say b squared, but I've already taken the square root to isolate that b. So b squared equals a squared plus c squared minus 2ac times cosine of b. We'll plug all of our numbers in that we know. And then with angle A, which we're interested in because that's going to let us know our orientation from where we started. So angle A, if we isolate, we set it up like this and we isolate that capital A, we're going to have cosine inverse of a squared minus b squared minus c squared minus 2bc. So I encourage you, if you haven't already, to pause and make sure that these make sense to you with your law of cosines formula. At this point, we're going to plug our numbers in and calculate those values. Now, one thing you'll keep in mind is I'm going to calculate little b, and I'm going to need little b over here. So we want to make sure while we're working through these calculations that we make sure to use an exact value or maybe to store an answer. So once I plug my values into both of my two formulas, this is what it looks like. Notice I've written answer here instead of actually that b value because I want to use the store function or the second answer, but that requires me to be able to type it all in one line. But point is I want to try and use that exact value, and I encourage you guys to take some time, practice, make sure you can do this in your calculator. So I've brought in a picture here of how I would work out b. So I would type all of this in on one line, making sure that my calculator is in degree mode because this angle is in degrees. So I have 170 squared plus 210 squared minus 2 times 170 times 210 times cosine of 68, close your parentheses. I get this large number, 46,253.89, 0.08923. And then I would take the square root and use my answer button, so square root and then second answer, which gives me that b is roughly 215. So b is, I'm going to say 215.07, and that unit measure would be in kilometers. So then what I did here is I pushed the store button. And the store button is going to say, hey, I'm going to store that previous answer. And then I typed alpha B to store it as 215. So that when I went to use my calculations for A, or to use B in my calculations for A, I should say, I calculate my argument, which is 170 squared minus B, because I've already stored it, B squared, minus 210 squared divided by, notice I have parentheses around my entire numerator and my entire denominator, negative 2 times the b value that I stored times 210, which gives me 0.6803369,473. So at this point then I do cosine inverse of that answer, which gives me that angle A is roughly 47.13 degrees. A is 47.13 degrees. Okay, so we found angle A, but that is angle A. That's over here in this part of the triangle. So we have 47.13. Is that my entire answer? So we want to know this piece of information. So what I'll need to do is from that 47.13, I need to remove this 32 because all of this is A and I just want this little tiny sliver over here. So once I did that, I have the 47. I took away 32, which gave me 15. So that means that this little piece right in here is 15 degrees, roughly. Now, rounded, of course, 15.13, I believe. Okay, so for our final answer, if we want to say that navigationally, we need to come all the way around full circle to this vector, and that's going to be 360 minus that 15. And you see that right here in my calculation, 360 minus the answer 15. So that means we are 215 kilometers from the start or the point of origin, and we are in a direction of 344.87, I'll round, degrees. And so that, ladies and gentlemen, friends of all kinds, that is our final answer. So I hope that helps you understand it. I didn't want to go through too much of me having to write all of this out because it takes so long, but I do encourage you, please make sure you can do this and you know how to use your calculator correctly, because that's where I see the biggest error with students is that they know how to write it on their paper, but they can't type it in the calculator to get the right number. Of course, you know, especially when you're dealing with my math lab, only the correct answer works. That's it. We solved a navigation problem using vectors. We solved a side angle side triangle, law of cosines. Email me if you have any questions, comments, concerns, just want to chat. Have a good day. Bye, guys.